another standard question. Very simple, but a bit technical. If you don't understand it, it might throw you off balance. An electric current of 3 amps flowing through an electric heating element of resistance 20 ohms, embedded in 1,000 grams, I repeat, 1,000 grams of an oil, raises the temperature of the oil by 10 degrees Celsius in 10 seconds. It's 10 seconds. Alright? 10 seconds. Full stop. Determine the specific heat capacity of the oil. Very simple. They just want us to determine the specific heat capacity of the oil. Option A, 1.8 joule per kilogram, okay, per degree Celsius, as it's option B, 0.6 joule per grams per degree Celsius. Option C, 0.18 joule per gram degree Celsius. And then option D, 0.06 joule per grams per degree Celsius. Okay? All these options have attachment per degree Celsius. Okay? Alright, so what do we do? As usual, we need to bring out our data first and then apply the appropriate formula for this. So the first thing is solution. Let's look at the solution first. And then our data, very, very important. What do we have? Current I. An electric current of 3 ampere. 3 amps. So I is given as 3 amps. Okay? Flowing through an electric heating element of resistance. Resistance is given R. R equal to 20 ohms. And then embedded in 1,000 grams of an oil, okay, raises the temperature of the oil by 10 degrees Celsius in 10 seconds. So mass M is equal to 1,000 grams. Temperature of the oil is 10 degrees Celsius. That is theta is equal to 10 degrees Celsius. And what else are we missing? Time, T, 10 seconds. T is equal to 10 seconds. Good. Okay. So, these are our data the question contains, okay? This is the information that the question contains. The next thing is what formula is most appropriate for this? Most appropriate for this. We recall that the heat is also given as mc theta. Good. So we can as well, since it is coming from an electric heating element, our heat now becomes, heat is equal to I squared, yes, I squared RT. Good. So we can use this. We can use this to evaluate for. So anywhere we see heat, we now have I squared RT is equal to mc theta. Okay, which are we looking for? We are looking for specific heat capacity. We are asked to identify, rather determine specific heat capacity of the oil. Okay? So that's C. The specific heat capacity is not given. That's what we are looking for. C. Alright? So we have C, we transpose C to be the subject here, becomes I squared, resistance and time all over mass of the oil and temperature of the oil, and theta. Okay? And finally, we substitute. How do we substitute here? For I, we have 3 amps for I. Okay? We have 3 amps, that's 3 ampere for I, that is current. 3 squared. Resistance, we have 10. Time, we have 10 seconds, okay? All over. Mass, 1,000 grams times. Temperature is 10 degrees Celsius. 10 degrees Celsius, okay? 10 degrees Celsius, that is it. So our specific heat capacity for the oil, see oil is equals to dash, put it here. So what do? As a student and a question has been solved up to this moment, up to this point, I mean, what you need to do is very simple. Take your calculator, 3 squared is 9, 9 times 10 times 10, you keep it, divide by 1000 times 10, and then whatever it gives you, you put it here as the answer, and it must correspond with any of this, with one of this. It must correspond to one of this as the answer. Okay? So I want you to do that. Put it in the comment section. Comment it in the comment box. If there are steps that you think are not clear, still comment such steps in the comments box, and we will discuss it further from there. Don't forget to give me some likes, okay? Subscribe, share with your fellow students, and make sure you give me comments. I want to hear from you. Things about this that are not clear to you, things you think are confusing, so that I will take time to clear your doubts. See you in my next class.